This is section 3.10, part B. And we're going to do some modeling this time with a table of values that's given to us. The speed of a computer depends in part on the chip speed. As technology advances, we've produced faster and faster chips. So for various years, you can see the maximum chip speed in megahertz for computers that year. We'll start by finding the best fit exponential equation that models the chip speed in the year that is t years after 1970. So let's start by making a little column for our t values here. 1 year after 1970, 4, 12, 22, 27, and 34, just subtracting 1970 from each of those. So I want to edit my data, and I'll put my t values in the first column, and then the chip speeds in the second column. It specifically says use an exponential equation, so I don't have to check the shape of the data this time. They told me what to do. And so we'll go ahead and go back into stat again and calculate our exponential regression. And there we go. I've got the A and the B, and notice the R squared of 0.95 is a pretty good fit, so I'm comfortable with this. So my equation, let's see, I'll use C for chip speed. We'll say C equals, A is about 0.2344, and B is about 1.31345. And that would be to the t power, t being our independent variable. What is the base? Our base B is about 1.313. And in terms of what it means, if I think of that as the percentage, 131.3%, subtract the 100% that we start with, and we see a positive or an increase of 31.3%. So the chip speed increases by 31.3% per year. All right, finally, use the model to predict the year during which chip speed reached 1,000 megahertz. So I'm told the speed, the chip speed, is 1,000. We'll put that 1,000 in for C. And solve for the t value. I need to isolate my exponential, so I'll divide by 0.2344. And that's about 4266.2. I'm going to keep that number in my calculator so I can use all of the decimals later on. And then I need to solve for t, so I'll use the logarithm function that's the inverse of that exponential. Again, another weird base, but that's okay. The log of, or base 1.31345 of 4266.2, and I'll do the log with the same base on the other side. Again, we chose that specifically because it's the inverse of the exponential function, so that's going to solve for t for us. And let's see here. If I go ahead and take the log base, 1.31345 of my previous answer. I've got about 30.66. And that's basically our answer. They did want us to predict the year during which the chip speed reached this. So if we keep in mind that this is a starting year of 1970, if I add 30 years to that, I would be in the year 2000. Notice it would be past halfway through the year, but it would be during the year 2000. And of course, all of these predictions are according to the model. I will point out that this seems reasonable given the original data set. 1,000 would be between 300 and 3,200. So sometime between 1997 and 2004 is a very reasonable answer. The year 2000 is what we got. All right, that concludes this section.